Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to go over how to solve one type of radical equation. A radical equation is simply an equation that has a radical in it. Now what these two problems have in common is that I'm going to be able to do these in one step, where I'm going to raise both sides to a certain power to clear the radical, and I won't have to do that more than once. In the next video, we'll take a look at ones where you have to do that a second time. First step is to isolate the radical, and in problem 7 I already have that. I have the square root of 3x minus 8 equal to x minus 4. So to get rid of the radical, I'm going to raise both sides to the second power. Square root of 3x minus 8 squared equals x minus 4 quantity squared. On the left-hand side, the square takes out the radical. I'm left with just 3x minus 8. On the right-hand side, though, to square that out, I want to multiply the binomial x minus 4 by itself. And I can do that through distributing the FOIL-style multiplication. So the left side is still 3x minus 8. On the right side, distribute the x. X times x is x squared. X times negative 4 is negative 4x. Then distribute the negative 4. Negative 4 times x is also negative 4x. Negative 4 times negative 4 is plus 16. Combine some like terms. 3x minus 8 equals x squared minus 8x plus 16. Now I need to collect all the terms on the right-hand side where the x squared is positive. So subtract 3x from both sides and add 8 to both sides. That gets me to 0 equals x squared minus 11x plus 24. And I'm going to try to solve that one by factoring. I need to find two numbers that multiply to 24 but add to 11, both being negative, and those are going to be negative 3 and negative 8. So I get 0 equals x minus 3 times x minus 8. And from there I can get my two solutions, x equals 3 or x equals 8. Now again, these are potential solutions because we're talking about real numbers here, and if you substitute that solution into a radical where you end up with a square root of a negative number, you can't use that solution. So the check, I really just need to check that 3x minus 8, the expression inside the first radical, is non-negative. So for 3, that's going to be 3 times 3 minus 8, 9 minus 8. That's positive 1. That's okay. For the 8, 3 times 8 minus 8 is 24 minus 8, or 16. That's positive, and that's okay as well. So my two solutions here are 3 and 8. Now, in the second example, because I have a cube root, there's a couple of changes. One is that we're going to raise both sides to the third power when we're able. The other is that you can take a cube root of a negative number, so we don't have to check our solutions like we did in problem 7. All right, the first thing that I need to do is I need to isolate a radical alone on one side of the equation, and I can do that by adding the cube root of x to both sides of the equation. That leaves me with the cube root of 3x squared minus 9x plus 8 equals the cube root of x. Now I can raise both sides to the third power. Whatever root you're taking, that's the power you need to use to get rid of it. So we'll raise both sides to the third power, and that leaves us with 3x squared minus 9x plus 8 equals x. Now I have a quadratic equation, and I need to subtract x from both sides to collect all the terms together. 3x squared minus 10x plus 8 equals 0. At this point, you want to try to factor this if you can. I know that if it factors, it would look like x and 3x. The only factors that I can use with 8 are 1 and 8 or 2 and 4. And I'm trying to find some mix that will allow me to add up and get a negative 10x. And let's see, this is the one that should do it. X minus 2 times 3x minus 4. If you distribute that out, x times 3x is 3x squared. X times negative 4 is negative 4x. Negative 2 times 3x is negative 6x. Negative 4 and negative 6x make negative 10x. And finally, negative 2 times negative 4 is positive 8. So this is the right factoring. And again, the advantage here is I can see my solutions almost immediately. The first is x equals 2. The other, 3x equals 4, or x equals 4/3. If you get the factor form, you can finish quicker. However, you may not see that factoring so well. And so at that point, you would turn to the quadratic formula. I'm going to use the quadratic formula as well, just to show you I end up in the same place. X equals, let's see, we've got A is 3, B is negative 10, and C is 8. X equals, the opposite of negative 10 is 10, plus or minus square root negative 10 squared minus 4 times 3 times 8, all over 2a, which is 2 times 3. Simplifying, x equals 10 plus or minus the square root. Negative 10 to the second power is positive 100. Negative 4 times 3 times 8 is negative 96. That's all over 6. 100 minus 96 is 4, and the square root of 4 is 2. So we end up with x equals 10 plus or minus 2 over 6. One solution, 10 plus 2 over 6 is 12 over 6, or 2. 10 minus 2 over 6 is 8 over 6, which can be reduced to lowest terms as 4/3. The same two solutions I had on the left. 4/3, comma 2. Right. So this is how we solve radical equations. Isolate the radical, or one radical on one side of the equation, raise both sides to the same power. To clear that radical, solve what you have left. In terms of checking, if you raise both sides to an even power, if you have a root that's an even root, you have to check to make sure that none of the radicands are negative. In the second problem that I did, because we were raising it to an odd power, we don't have to worry about that. Right. In the next video, we'll take a look at some problems involving radicals where we're going to have to actually square both sides twice. And we'll show you that in the next one.